A stressful situation, whether something environmental, such as being chased by a bear, or psychological, such as persistent worry about failing an exam, can trigger a variety of different physiological changes. For instance, a stressor can make your heart pound faster, eyes to dilate, and beads of sweat to appear. Experiencing stress can disrupt homeostasis, which is an organism's ability to maintain internal balance. When stress shifts homeostasis, the body will react and trigger a stress response. This is where the hypothalamic pituitary adrenal, or HPA axis, comes into play. The HPA axis controls an important hormonal response to stress. The HPA axis is triggered by the brain and causes the release of hormones into the bloodstream to send information to the body. A stressful event will activate the hypothalamus, an area of the brain that helps maintain homeostasis and control our stress response. Once the hypothalamus is activated, it releases corticotropin-releasing factor, or CRF, to the pituitary gland. When the pituitary detects CRF, it releases ACTH, or adrenocorticotropic hormone, into the bloodstream. ACTH travels to the adrenal glands, which will then release cortisol. Cortisol is a stress hormone that can regulate our stress response by helping release stored fats and converting proteins into glucose, which can be used as energy in stressful situations. This can give you energy, for example, to help run away from that bear. Cortisol can also, quote, shut down functions that are not necessarily essential for confronting a stressor, such as your digestive system or reproductive systems. When cortisol levels increase in the blood, cortisol itself can feedback and stop the release of CRF from the hypothalamus and ACTH from the pituitary. As a result, ACTH levels start to drop, which then leads to a drop in cortisol levels. This is called a negative feedback loop and helps control excessive cortisol secretion. Proper functioning of the HPA axis is essential for dealing with stress short term. However, reacting to chronic stress can cause allostatic load, which is damage caused by our body's attempt to maintain homeostasis under prolonged periods of stress. Chronic stress is often associated with many negative outcomes, such as depression or anxiety. Even though too much stress can have negative outcomes, a little bit of stress can be good. If you didn't feel stress when chased by a bear, then you wouldn't know when to flee. If you didn't feel a little bit of stress before an exam, you may feel less motivated to study. So as you can see, our body's ability to detect and deal with stress is important. Even though some effects of stress are not always pleasant, just remember, it's your HPA axis just looking out for you.